In this video, we are going to discuss the differences between strong acids and weak acids, or strong bases and weak bases, both at the molecular level and in terms of what they do to pH. So, what is the difference between a strong acid and a weak acid? Well, if we're talking about acids, okay, we know that acids are molecules that donate H+, hydrogen ions, according to the Bronsted-Lowry definition. Okay? Because we learned that if there are H pluses around, the more H pluses there are, that is a lower pH. So if we have a strong acid, that means we have a lower pH, closer to 1, further away from 7. So how does a molecule make H plus? Well, it has to dissociate. So for an acid, we'll just call, acid HA, where this element A is just any anion. When HA gets into a solution, what happens is that it dissociates. It makes H plus and A minus. So what happens, if something is a strong acid, what it does is that it completely dissociates. Another way of saying that is that what completely means is that all molecules separate. So every single molecule of acid splits into H plus and A minus. Okay. On the other hand, if you have a weak acid, the difference here is that it only partially dissociates. Which means that only this word partially, what that really means is only some molecules split apart. A common misconception is in the difference between completely and partially. A lot of students think that completely means they're very far apart. So like this versus this is only partially dissociated, but this and this is completely. The distance the molecules are apart or the ions are apart has nothing to do with if an acid or a base is strong or weak. What you care about is how many molecules, all of them or some of them. The same is true for bases. Weak bases only partially dissociate, strong bases completely dissociate. So if we were to look at a diagram here, they're already labeled strong acid and weak acid. But let's look at the ions inside the solution to figure out why. So here we have red sphere and a white sphere, which we can see is our acid. The white sphere we'll call the proton, which is the H plus, the hydrogen ion. The red one is like our A minus. And when they're together, that's our HA. So we said the strong acid should completely dissociate, which means that all molecules should be split apart. Well, let's look what's happening in the solution. We start with HA bonded together. Here, A minus, A minus, A minus. Every single ion is separate. They're all dissociated. On the other hand, over here with our weak acid, we know the definition is that this should only partially dissociate. And we know that partially only means that some of the molecules should dissociate. Well, let's see if we have that. Here I see something that's dissociated, but look, we also have HA still together, where the red and the white sphere are still bonded. So clearly only some of the molecules are dissociated. If you have more H plus, another way of saying that is if there is more dissociation, more splitting apart, that means you have a stronger acid. So let's see if you can apply this now. This question says hydrobromic acid, HBr, is a strong acid. If 3 molecules of HBr in a flask, what would they look like? So go ahead, pause the video, and in this flask here, draw 3 molecules of HBr if it's a strong acid. You can use just HBr as the molecule. So what would it look like? Well, we have 3 HBRs that we need to start with, and we need to decide how are they going to dissociate. Since this is a strong acid, that means that it's going to completely dissociate. All molecules are going to break apart. So when this is in a solution, every single one of these is going to split. So we're not going to have any HBRs still stuck together. So this one's going to split apart into H plus and Br minus. Same with this one, H plus, Br minus, and this one, H plus, Br minus. So this is what the solution will look like if this was a strong acid. The follow-up question would be, what would it look like if it's a weak acid? Well, a weak acid, only some would dissociate. So if we had a weak acid as a follow-up, maybe you have H plus and Br minus, H plus, Br minus, but some molecules still need to be bonded together. HBr still stuck together. This would represent a weak acid because not all molecules are dissociated. So as you go back to the language of the learning target, ask yourself, can I explain the difference between a strong acid and a weak acid? And can I show that with models of the ions in solution?